Hi guys, hope you're doing good. Here's video number 2. This is just on solving a quadratic equation and where that imaginary unit actually comes into play and why it's important for us in Algebra 2. So what I want to talk about first is I want to talk about just like solutions to quadratic equations. So a quadratic equation is just a parabola, and when we're talking about a solutions to equations that look like x squared plus 3x plus 4 equals 0, we're usually talking about equations or solutions are x-intercepts. So if I were to graph this equation, actually let's make this be a minus so it makes a little more sense. It would probably look something like this. And the solutions to this equation would be where it is crossing the x-axis. So if it crosses my x-axis 2 times, that means it would have 2 real solutions, and those would be 2 real x-intercepts. Another possibility for a quadratic equation is a quadratic equation could just bounce off of my x-axis. And so that one would have just one real solution, one real place where it touches the x-axis, so one real solution. Oops, that's not how you spell solution. Or x-intercept, so remember those words are interchangeable. And then another possibility is you have a quadratic that never touches the x-axis. So what that means is this has 0 real solutions because it doesn't have an x-intercept. But this still has solutions. It just has 2 complex solutions, which means that there's an imaginary aspect to it. And we'll talk about that in a second. But these are your possibilities for quadratics. You could have 2 real solutions, you could have 1 real solution where it just touches your x-axis, or you could have your parabola shifted up above the x-axis where it has 0 real solutions and 2 complex solutions. So we're gonna go through one. And what we're going to do is we're going to just plug this equation in our calculator, sketch a graph, and then go from there. So let me pull up my calculator here. Slowly but surely, we're going to make it. Okay, so I'm going to start by just plugging this quadratic equation into my calculator. So I'm going to do x squared minus 4x plus 5. And then I'm going to go to the graph. So looking at this graph, it looks like it comes down here. It has a y-intercept of 1, 2, 3, 4, 0, 5, and then it comes down to being really close to the x-axis at 2. So if we're going to sketch a little graph of this, I'm going to draw myself an xy axis. I know it has a y-intercept at 5, so I'm going to draw that in. And then I know at x is 2, it looks like maybe the bottom of my parabola is at 2, 1. And then I'm just going to sketch in a parabola. So that's what my parabola looks like based on the graph. Okay, and then here's the question, the first one. Does this graph cross the x-axis? So this does not cross the x-axis. So what this tells us is it has 0 real solutions because it doesn't touch the x-axis, but it is a degree 2, it is a quadratic, so it should have 2 solutions of some type. This means it's going to have 2 complex solutions, which have an imaginary aspect to them again. Okay, so complex numbers are numbers that are written in the form a plus bi. So there's 2 parts to it. You have a real part, which is this a part, which is seriously any number. It could be like 5 or 1/2 or 2 or any real part, any real number. And then the second part right here, this bi, is the imaginary part because it has that imaginary unit, right? And then this b and the a are both real numbers. The I just tells you that this part is your imaginary part. So we're going to solve this quadratic equation and we're going to see that it gets a complex answer to us, and then we're going to be able to interpret that a little bit further. So this says now we're going to use the quadratic formula to solve this x squared minus 4x plus 5. So let's just remember quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then if I have my equation x squared minus 4x plus 5 equals 0, the a is 1, The b value is -4, and the c value is going to be that +5, and the signs do matter. And then you're just going to plug it in. So x equals -b, so -4. So negative stays the same, and then I take this b value and I plug it in there, plus or minus the square root of b squared, so you got to put this in parentheses, -4 squared minus 4, a value is 1, so times 1, times c, which in this case is 5. And then all divided by, so make sure you're dividing that -4 also, 2 times a, and our a value is 1 in this case. So I seriously just took the a, b, c and plugged it in where it fit in the formula. And now we're going to start simplifying. So if I have -4, this becomes +4, plus or minus, and then I still have the square root. -4 squared, so -4 times -4 becomes +16. And then I do all of these together. So I'm going to do -4 times 1 times 5. So -4 times 1 is -4, times 5 is -20. So then this is going to be -20. And then I have all divided by 2 times 1, which is just 2. Okay, then we're going to keep going. So 4 stays the same, plus or minus the square root. Now in here, this is 16 minus 20. So if I take 16 minus 20, we get -4 divided by 2. Now remember, this is where we usually get stuck and say it has no real solutions, which is true. It doesn't have real solutions. It has complex. But we can take this and now simplify using our imaginary unit. So I'm going to write this as 4 plus or minus. I can break this square root of -4 into -1 times 4. And then I know the square root of -1 right here becomes I, and the square root of 4 becomes 2. So I can keep the rest of my equation the same and write this square root as 2i, because the square root of 4 was 2, and the square root of -1 was I. And then I have this all divided by 2. Now I can take this one step further because the 4 is divisible by 2, and this 2 is also divisible by 2. I have to make sure that it goes into both parts of this equation because this plus or minus is here. So I'm going to start by doing 4 divided by 2. So that becomes 2. Keep the plus or minus, and then 2i divided by 2 just becomes I because the 2's cancel out. So what we get is we get x equals 2 plus or minus I. So now if we're going to write the solutions, because we really just solved for x-intercepts, you're going to have one x-intercept be 2 plus I. So x is this when y is 0, and x is 2 minus I when y is also 0. So these are both your complex numbers, and they're both our complex solutions, where you have the 2 is the real part because 2 is a real number, and then this is a 1i and a -1i, and so that's your imaginary part. So your solutions are those. And that's how you guys solve using your imaginary units. You guys are gonna have problems like this on the homework where you have to do quadratic formula and all of that stuff. Okay, we have one last example. So this is an example of solving after you've completed the square, because this is in vertex form. So we're trying to solve, and I'm going to first replace y with 0 so that we're trying to find x-intercepts. Actually, I'm going to write the 0 over there. Okay, so ultimately we're trying to solve for x. So the first thing I'm going to do is I'm going to subtract 9 from both sides. So then I've got x plus 5 squared equals -9. Now the next thing we need to do is we need to get rid of this squared right here. So I'm going to do a square root of both sides. Remember, when we physically write that in, you have to put a plus or minus in front. On this left side, those cancel out, and I'm left with x plus 5 equals plus or minus the square root of -9. Now we know how to simplify the square root of -9. I can break this into the square root of -1 times 9. Don't forget the plus or minus. Then I know the square root of -1 is I, and I know the square root of 9 is 3. So this whole expression becomes 3i with the plus or minus in front. And now my last step is just to get x all by itself, so I need to subtract this 5 to the other side, so -5 minus 5. I am not allowed to combine this -5 and the 3i, because think about this like terms. This one has the I and this one doesn't. So it's like if this were a 5 and this were a 3x, you would not be allowed to combine them. So we write this as -5 plus or minus 3i. So then we have two solutions because that plus or minus. So we're going to write them as points. So I have -5 plus 3i comma 0. So this is x when y is 0. And then I also have negative 5 minus 3i, because that plus or minus could be a positive or a negative, comma 0. So these are my two complex solutions to that quadratic equation, which means it doesn't cross the x-axis, and those are going to be my solutions that make my equation true. Okay, so you guys are going to do a couple of these on the homework. I don't know if this actually, tonight's homework has this, but your next homework next week is going to have this on it, or for next class, not next week. As always, if you're confused, please reach out. I really hope you guys are all doing okay and that everybody's well. And I just want you guys to know I really miss you. Bye, guys.